take a look at a few more results that we should be aware of when it comes to cardinalities of sets. So the one fact that we have is that any closed interval from A to B is going to have the same cardinality as any other interval from C to D. So if you have some interval that has the same cardinality as any other interval, doesn't matter how big or how small. Same thing is going to be true if you have open intervals. So if you're not including the endpoints, the same thing is going to be true. So what we can ask this question then, because in general we have this, but these are for finite numbers, A, B, C, and D. What if we had something where we wanted to look at all of the real numbers? Does negative pi over 2 to pi over 2, does that have the same cardinality as all real numbers? Well, if it does, we have to find a bijective function that works. So are there any functions that you can think of that have a domain of this whose range is this? So if they have a domain of this, range of this, and they're a one-to-one function, there is one that you're aware of, right? So we could think about the function that's going to map negative pi over 2 to pi over 2 gets mapped to the reals where f of x is equal to tangent of x. Right? If we think about what tangent looks like on this interval from negative pi over 2 to pi over 2, we have our vertical asymptotes there, but we have everything in this region gets mapped to all real numbers. And this, it passed the horizontal line test. This is a one-to-one or an injective function. And this is also surjective. So this is a bijective function. So indeed, this statement here is true. But because we did say that any open interval has the same size as another open interval, what this can now be concluded as is that 0 to 1 has the same cardinality as all real numbers. So you could somewhat see it as there's the same number of elements between 0 to 1 as there are as all real numbers. So we have this understanding of cardinality by using these proofs. Now, at this point, maybe you're fully grasping this and this is awesome, but there should be a part of you that says, this is very counterintuitive. What I'm seeing here, it doesn't make sense until I start to look at some of the rigor, right? So just add from a very big picture outside standpoint, right? You try to tell someone that there's the same number of numbers between 0 and 1 as there are real numbers, they'd be like, you're an idiot. That makes no sense at all. So what I'd like us to start to recognize is that there's other things that if we can start to recognize some of these seemingly counterintuitive ideas, it seems to be false, right? It seems to not make sense with us. But then the more we delve into it, it actually does seem to make sense. I'd like us to use mathematics as one of those foundations. So I want to take a look at this example here. So if we have the set consisting of all of the numbers that are congruent to 0 mod 3, and I think all the set of all elements that's congruent to 1 mod 3 and then 2 mod 3. We know that these three sets, these are all subsets of the integers, right? They're proper subsets. They're not obviously equal to themselves. So if we look at the union of all of these, if I form the union of these three sets, well, that is now going to consist of all integers, right? But also note here that A has the same cardinality as B, which has the same cardinality as C, right? These all have the same cardinality, but also A has the same cardinality as all the integers, and B has the same cardinality as all the integers, and C has the same cardinality of all the integers. So what you have here is you have three sets that have the same cardinality as this bigger set, but yet they all together form this bigger set. And so what I like a lot about this understanding is that this helps me wrap my mind a little bit about the biblical doctrine about the Trinity. So the Trinity talks about how we have this, in the Christian tradition, we have this one God, but then there's three persons. You have the Father, the Son, and the Holy Spirit. Somehow they're all God, but then they all are form God. It gets really crazy. It seems very counterintuitive. It's one of the things that for a lot of people, they're like, Christianity doesn't make any sense. How could you possibly have three persons with one God and all of that? when I think about sizes of sets and cardinality, these are things that are very counterintuitive, but yet they're actually still true. And so when we come across some of these, my hope is that this might help us understand a little bit more about something like the Trinity, right? It's still a huge mystery, but allowing us to study mathematics at this level allows us to have a better understanding of what Christianity is really saying and realize that these seemingly counterintuitive, these contradictory, these paradoxical things could still be true, and they still make perfect sense. This still makes a whole lot of sense, and you shouldn't be doubting now that any of this is true. This is still very true. But this is, I think, a really nice way to start to apply this to understanding Christianity.